Hi and welcome to Chemipedia chemistry classes for 11th and 12th standard. So in this video I am going to teach you a simple trick to find the number of isomers, the total number of isomers for alkane compounds. So till carbon number 7, that is up to carbon number 7, to find the total number of isomers, there is a common formula 2 power n minus 4 plus 1. 2 power n minus 4 plus 1. Here n is nothing but number of carbon atoms of the alkane, whereas here n value up to 7 you can use it, isn't it? So let us check the number of isomers for the different alkanes. If n value is 1, is nothing but methane. So methane is the alkane with n value 1. But now if you substitute the n value in the formula, 2 power 1 minus 4 plus 1, isn't it? 2 power minus 3 plus 1. This is a negligible value. So I take it as 0 plus 1, 1. So that for the first alkane, methane, there is only one isomer. There is only one isomer, isn't it? Right. The next member is nothing but ethane, isn't it? So C2S6 or CS3 single bond CS3. For this, the total number of carbon atom is about 2. So when we substitute the formula, I am getting 2 power 2 minus 4 plus 1. 2 power minus 2 plus 1, isn't it? So this is a negligible value, 0. So plus 1, 1. So for the next alkane, that is ethane also, I am getting only one isomer, isn't it? Right. Then the third one is nothing but propane, isn't it? With the molecular formula C3H8 and can be written as CS3 single bond CS2 single bond CS3, isn't it? Right. But now I am substituting n value in the formula, so that I am getting 2 power 3 minus 4 plus 1. That is equal to 2 power minus 1 plus 1. Being a negligible one, we can neglect this. So you get only one. So even for propane also, there is only one isomer possible, isn't it? Right. So now we move on to the fourth member of alkane derivative. The fourth member of alkane is nothing but butane, isn't it? Right. Now, so first let us calculate the number of isomers for butane. N value is 4. When we substitute, I am getting 2 power 4 minus 4 plus 1. It's nothing but 2 power 0 plus 1. Anything power 0, 1 only. So 1 plus 1. So I am getting 2 isomers. Which means for butane, there are 2 isomers possible. So I have drawn the structural formula of the 2 isomers. The linear one, what do you call it as N-butane. The other one, which has one carbon in the branch, which is nothing but isobutane. So these are the 2 isomers which are possible for butane compound, isn't it? Right. Now suppose if n is equal to 5, if n is equal to 5, which is nothing but pentane compound, isn't it? Right. Now let us substitute in the formula 2 power 5 minus 4 plus 1. It's nothing but 2 power 1 plus 1. So totally I am getting 3 isomers. Whereas in case of pentane, so there are 3 isomers are possible. Okay. The first one is nothing but a normal one, in which the 5 carbon atoms are arranged in an unbranched manner, which is nothing but N-pentane. The second one, in which one carbon is in the branch, isn't it? So CS3, CH, CS3 pattern, so iso compound, so nothing but isopentane. The third one, in which 2 carbon atoms are in the branches. I write one carbon in the upper branch and another carbon in the lower branch. So this compound is nothing but neopentane. So that in pentane case, there are 3 isomers are available. N-pentane, isopentane. The third one is nothing but neopentane. Okay. Similarly, we can calculate for the other members also. Okay. So now I am going to calculate the number of isomers for an alkane with carbon number 6, which is nothing but hexane. Am I right? Okay. So substitute that n value in the formula. 2 power 6 minus 4 plus 1. That is 2 power 2 plus 1. 2 power 2, 4 plus 1. So I am getting about 5. So which means in case of hexane, there are 5 isomers possible. 5 isomers possible. As usual, the first one is nothing but a normal one, unbranched one, which is nothing but N-hexane, isn't it? Then second compound, I write one carbon in the branch, so that I get an iso structure. Longest carbon chain with 5 carbon, pentane, methyl group at the branch. So second carbon it is attached, so that 2 methyl pentane. That's the second isomer. Then the methyl group you can have at the third carbon, isn't it? Exactly at the center. So that carbon will get number 3. So longest carbon chain, parental carbon chain, pentane, methyl group methyl pentane, it is at carbon number 3, so 3 methyl pentane. That's the third derivative. Fourth one, you can have 2 carbons in the branches, isn't it? So I am getting this another derivative, parental carbon chainless, so 4 carbons are there. It's a butane, dimethyl butane. Both methyl groups are at second carbon. Least number, I go in a forward direction 1 2, isn't it? So 2 methyl butane, 2 comma 2 dimethyl butane. That's the fourth isomer. The last one is this one. Okay, you can have the branches at carbon number 2 and 3. So I now either you number this way or this way. These carbons are getting 2 and 3, isn't it? 2 3 or 2 3. This is butane. 2 methyl groups are the branch substance. So dimethyl butane. One at second carbon, another one at third carbon. So this is named as 2 comma 3 dimethyl butane. These are the 5 isomers of hexane. That is N-hexane, 2 methyl pentane, 3 methyl pentane, 2 comma 2 dimethyl butane. Then the last one is 2 comma 2 dimethyl butane. Right. For carbon number 7, that is heptane also, you can use the same formula. So I am substituting N in the formula. So I am getting 2 power 7 minus 4. 2 power 7 minus 4 plus 1 is nothing but 2 power 3 plus 1. 2 power 3 is nothing but 8. 8 plus 1, 9. So that for heptane, so I will be getting about 9 isomers. Okay. Whereas the other members, that is alkanes with carbon number 8, 9 and 10, we have different formula. Okay. Right. Whereas carbon number 8, the formula is 2 power n minus 4 plus 2. So far we use plus 1 from 8 for 8th carbon derivative, 8 carbon derivative, 2 power n minus 4 plus 2. Okay. When you substitute the values, probably you will get about 18 isomers, isn't it? Whereas for carbon number 9, the formula is 2 power n minus 4 plus 3. Plus 3. So for carbon number 9 alkane, so we are getting 35 isomers. How many isomers? 35 isomers are possible. The last one, an alkane with 10 carbon atoms. The formula is different from 8th and 9th also. Okay, so the formula is 2 power n minus 4 plus 1 plus n. Okay, so now when you substitute 10 in the formula, in the place of n, 2 power 10 minus 4 plus 1 plus 10. So number of carbon atoms in the alkane. So finally I am getting about 75 isomers. For alkane with 10 carbon atom, there are 75 different isomers possible. Okay, right. So this is how to find out the total number of isomers for alkanes starting with carbon number 1 to carbon number 10. Right. Thank you.